So in this video, we are going to go ahead and start talking about types of slope and slope from a graph. So the slope just measures the steepness of a line, okay? And it measures the change in your y, which is the rise, which is how far up and down, and the run, which is the change in your x, which is how far side to side. Your slope is constant. It's never going to change throughout the line. Since your line is a straight line, it doesn't have all these bumps and everything, your slope's going to stay the same. This is going to make us more sense in a little bit once we actually look at this from a graph. But first thing we're going to talk about are the 4 types of slope. So the first one right here, the way that I like to think about it, if you put a little person on this line, right, they're going to have to climb up your slope. They have to climb up. As you can see, it goes up as you go from left to right. Your line goes up. So this slope we call positive, right? This is our positive slope. You're climbing up the hill, or as you're looking at it from left to right, it goes up. Always, always left to right. Just like if you're reading a book, all right, always left to right. That's our positive slope. In comparison, if we put a person on this slope, they're not going to climb. They are going to take a tumble, right? They are going to roll down the hill. If you look at this from, there we go. If we look at this from left to right, it goes down. So this slope is, shocker, negative. Right, just think going down. You think of your axes, right? Negative. Okay. Those are our first 2, positive, negative. These have our people. Our next 2 are not going to have our people, but they're a little special. So this first one, this is a horizontal line. If you put a person, they're not moving, right? They're going nowhere. So horizontal, yeah, there we go. Not moving. All right, so this will make more sense later on the unit. Horizontal lines are always going to be written as y equals some number. So since you're not moving at all, this is a 0 slope. Okay, my little trick for this is actually not the person, but if you write the word 0, you can draw horizontal lines through the z. Okay, horizontal lines through the z. Our last slope, this is a vertical line. This will always be written as x equals a number. If you put a person on here, yikes. That is a instant drop. But also, this wouldn't happen, right? You'd never be at something going straight up and down. So this slope is called undefined. If you don't want to write undefined, you can use this little symbol to mean doesn't happen, not possible. Okay, and the little trick for undefined, if you write undefined, you can draw vertical lines through that first letter. Okay, so these are the 4 types of slope, all with our little people to understand what's happening. Okay, now we're going to expand this and we are going to look at slope from a graph. Okay, so our slope, as we mentioned earlier, is rise over run. So I like to think you have to get up and out of your seat before you can run for the door, okay, when the bell rings. Okay, our rise, all of this up top, our rise is how far up and down you have to go. So that's the change in y. This triangle is just a Greek letter called delta. That means change. Okay. Mathematicians are inherently very lazy. So we like to have little symbols for things. So change in y. So rise is how far up and down. Run is going to be how far left and right. So that has to do with our x value. So that's this understanding. Now, we need to find our 2 perfect points on a graph. Okay, this graph doesn't give you points. Some graphs will. Okay, so a perfect point is a point with whole number coordinates, no decimals. I think decimals are the worst. All right, so if we look at our graph to find perfect points, this one would be perfect. We can easily write that as 0, -2. This one, I don't, -3.2, comma, -3.8, question mark, I don't know. Like, that's weird. That's gross. Not perfect. That's going to be really, really hard to count. So you always want to look for points that are right in the corner of these boxes as well. So as you can see, all of these out here that I'm marking, these are all going to be perfect. They're nice and neat. You can easily rate them as an ordered pair. Okay, so that's step 1. And you only need 2 points, okay, to find slope. You can use this one and this one, this one and this one, this one and this one. Like, it doesn't matter. You just need 2, okay? So we have our points. Now, we're going to count our rise over run. So I'm going to go ahead. I'll use this one and this one because why not? All right. You can only move up and down and left to right. You can't travel along the diagonal. You have to go straight up and down, straight left and right, kind of like chess. All right, so we went up 2. Each box counts as 1, so it'll hop, hop. And now we're going to hop over 1, 2, 3, 4. Over 4. Looking at this, we can tell that this is a positive slope. All right, just from looking at our line. So our rise is 2. Our run was 4, so let's put that together. Our slope, we use an M, 2 over 4. We can simplify that fraction, okay? If you don't know how to simplify the fraction, type it into Desmos and click that button. It gives you the most simplest fraction. That's going to simplify to 1 over 2, okay? 1 over 2. The most important thing is always start up and down and then left or right. Because if you don't, it can just start throwing you off and then your slope's going to be backwards. And then, oh my gosh, all these bad things happen. Okay. All right. So let's do another one. Let's look at these. All right. These 2, we have our line for us. So remember, we have our rise. So that's how far up we went up 1. So our rise is 1. And then our run, 1, 2 over 2. It's 2. We can't simplify this fraction anymore, so that's it. Our slope is just 1 over 2. This one, we have points given to us. We have our rise. I'm going to always start on the left. We're going to go down 1, 2, 3. Down 3. It's really important to note that down and left give you negative numbers. Up and right give you positive numbers. So if you think of the axes, down and left, those are all negative numbers. Up and right, those are all positive numbers. So our rise is -3 over our run, which is over 1, 2, 3, 4. Since we went to the right, is a positive 4. We cannot simplify that fraction, so our slope, -3 over 4. Okay? Let's look at 2 more, because this stuff's not too bad. This one, we are not given our points, so we need to find our perfect points. So we have 1 here, and if you're really careful, you can see that that's not a perfect point. However, if you were to put your point here, you can go along and see that you don't have any other perfect points until you get here. Something really, really important to note. Your perfect points need to be the same distance apart, right? Because the distance is our slope, all right? And so our slope is constant. Our slope does not change. These do not look like they are the same distance apart. They are way far away. I made the same mistake, okay? I counted that one initially, and I was like, ooh, wait, whoops, what did I do? Okay, so we're going to go ahead and find our slope. So we're going to go down 1, 2, 3, 4, 5, 6, 7, 8. Down 8, that tells me -8. And then we're going to go over 1, 2, 3, 4, 5 to the right 5, which is a +5. Last time I checked, 5 does not go into 8. So that's it. Our slope is -8 over 5. All right. Last one, kind of. We have to pick our perfect point. So we have 1 here, and 1 here. So we have our rise over run. We're going to go up 1, 2, up 2, and over 1, 2, 3, 4, 5, 2 over 5. Can't simplify that, so that is going to be it. All right, now since we have 3 perfect points on this graph, what I want to show you is that it doesn't matter what points you use. You're going to get the same answer. So let's look here, rise over run, and use our 2 endpoints. All right, so let's see. We're going to go up 1, 2, 3, 4, up 4, so a +4, and then over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Whew, that was so many. 4 over 10. This fraction can simplify, okay? Put it into Desmos. Click on this button, and it will tell you that your slope simplifies to 2 over 5. Okay, which look at that. Same thing as we got before.